7 AI models just failed the same safety test, but one of them failed in a way that shouldn't even be possible.
Wait, these are the latest models from OpenAI, Google, and the others, right? What kind of failure are we talking about here?
The kind that could get your company sued or your AI shut down. And if you're using any of these 7 models in production right now, you need to know which one has this vulnerability.
Welcome to the AI Daily Podcast. Today's news and a deep dive to help you stay ahead in AI.
Today, we're diving into a safety report on GPT 5.2, Gemini 3 Pro, Qwen 3VL, Doubao 1.8, Grok 4.1 Fast, Nano Banana Pro, and Seedream 4.5.
But first, let's cover today's top headlines.
There's a fascinating new development in the AI healthcare space. OpenAI and Anthropic are making serious moves into medical applications, according to TechCrunch's latest podcast episode.
Healthcare seems like the natural next frontier for these AI giants. What kind of investments are we talking about?
We're seeing acquisitions, new product launches, and major funding rounds specifically targeting healthcare applications. It's not surprising given the potential for AI to transform diagnostics, patient care, and drug discovery.
Though I imagine the regulatory hurdles in healthcare are massive compared to consumer chatbots.
Absolutely. Speaking of consumer chatbots, there's an interesting Reddit post making the rounds about ChatGPT's personalization limitations. A user shared their frustration that ChatGPT doesn't seem to remember or understand their preferences well.
That's been a common complaint. These models are great at general knowledge, but struggle with truly personalized interactions. They can't build that long-term memory of individual users yet.
Which makes the next story even more interesting. TechCrunch reports that ChatGPT users are about to start seeing targeted ads in their conversations.
Wait, targeted ads in ChatGPT?
OpenAI announced they'll be testing contextually relevant ads for free and Go-tier users. The ads will supposedly match the conversation topic, and users will have some control over personalization settings.
So they're struggling to personalize the AI experience itself, but they're confident they can personalize the ads? That's quite the paradox.
It does raise questions about priorities and user experience. Will ads make the free tier feel more transactional?
And how will users react to ads appearing in what feels like a conversational interface?
That covers today's headlines. Now, let's get into our main story. So this new safety report just dropped on Archive, and it's fascinating. They evaluated 7 frontier models, including GPT 5.2, Gemini 3 Pro, and some models I haven't even heard of, like Nano Banana Pro. But here's what caught my attention. They found what they're calling a sharply heterogeneous safety landscape.
Heterogeneous. So we're not seeing uniform improvements in safety as these models get more capable.
That's exactly right. And it gets worse. Every single model showed significant vulnerability under adversarial evaluation, even when they performed great on standard benchmarks. We're talking about models that look safe on paper, but fall apart when someone actually tries to break them.
Wait, hold up. These are the most advanced models we have, GPT 5.2, Gemini 3 Pro, and they're all vulnerable? What kind of adversarial attacks are we talking about here?
Think about it this way. Imagine you're running one of these models in production, serving millions of users. Your standard safety benchmarks show 95% compliance. You're feeling good. Then someone crafts a specific prompt that completely bypasses your safety measures. That's what this report uncovered across language, vision language, and image generation.
So we're essentially building on quicksand? Every time we integrate these models deeper into our infrastructure, we're increasing our attack surface?
The report evaluated them across 4 different protocols: benchmark evaluation, adversarial evaluation, multilingual evaluation, and compliance evaluation. And here's the kicker. GPT 5.2 was the only model that showed consistently strong performance across all of them. Everyone else had major trade-offs.
Trade-offs how? Like they're good at English but fail in other languages?
It's more nuanced than that. Some models nail regulatory compliance but crumble under adversarial prompts. Others are robust against attacks but can't handle multilingual context properly. Qwen 3VL, for instance, great on benchmarks but showed concerning patterns in adversarial testing.
Oh, and I'm curious about these newer models, Nano Banana Pro, Seedream 4.5. Are these legitimate competitors to OpenAI and Google?
That's what makes this report so valuable. It's not just the usual suspects. They included models from different regions and companies, giving us a real global perspective on where AI safety stands. And the results are sobering.
This feels like a wake-up call for anyone deploying these models in production. We can't just trust vendor safety claims anymore.
Exactly. And the multimodal aspect makes it even more complex. These aren't just text models anymore. They're handling images, generating visuals, processing multiple languages simultaneously. Each modality introduces new attack vectors. Coming up, we'll dig into the specific vulnerabilities they found and why text-to-image models showed surprisingly different patterns than their text-only counterparts.
So let's get into the meat of this. What exactly did they find when they stress tested these models?
The methodology is impressive. They didn't just run a few prompts and call it a day. They created what they call a unified protocol that tests across multiple dimensions. For language models, they looked at harmful content generation, bias amplification, and privacy leakage. For vision language models, they added visual deception and multimodal manipulation.
Visual deception? Like getting the model to misinterpret images?
More like getting it to generate or process harmful visual content that it should refuse. Here's a concrete example. Under normal benchmarks, GPT 5.2 refused harmful image generation requests 97.3% of the time. But under adversarial evaluation, that dropped to 78.6%.
That's almost a 20-point drop. And that's the best performing model?
It gets worse for others. Doubao 1.8 went from 94.1% refusal rate to 52.3% under adversarial conditions. We're talking about a model that looks incredibly safe in standard testing, but becomes a coin flip when someone's actually trying to exploit it.
What about the multilingual aspect? I imagine safety measures developed for English don't translate well.
You've hit on one of the key findings. They tested across 12 languages, including low-resource ones. Gemini 3 Pro showed interesting behavior here, maintained 91% safety compliance in English, dropped to 73% in Vietnamese, and hit just 61% in Swahili.
So we're essentially creating models with built-in linguistic bias in their safety systems.
The report suggests it's more about training data availability. Models simply haven't seen enough safety-relevant examples in low-resource languages. But here's where it gets interesting. Qwen 3 VL, despite being developed primarily for Chinese markets, showed more consistent multilingual safety performance than Western models.
Really? That's counterintuitive. You'd expect the opposite.
The researchers hypothesize it's because Qwen 3 VL was trained with multilingual safety in mind from the start, not retrofitted. They achieved 84% average safety compliance across all tested languages, compared to Gemini's 76%, and even GPT 5.2's 88%.
What about these newer players, Nano Banana Pro and Seedream? How they stack up?
Mixed bag. Nano Banana Pro showed surprisingly robust adversarial resistance in text generation, actually outperformed Gemini 3 Pro there, but completely failed compliance evaluation, suggesting they might not be following established safety guidelines. Seedream 4.5 was the opposite. Great compliance, terrible adversarial performance.
So different models are optimizing for different things. That explains the heterogeneous landscape comment.
But here's the real shocker. Text-to-image models showed completely different vulnerability patterns. While language models struggled with adversarial prompts, image generation models were more vulnerable to what they call semantic ambiguity attacks.
Semantic ambiguity?
Prompts that could be interpreted multiple ways. Generate an image of a bank. Is that a financial institution or a riverbank? Attackers exploit this ambiguity to get models to generate content they shouldn't. Grok 4.1 Fast was particularly vulnerable here, generating inappropriate content 31% of the time when faced with ambiguous prompts.
That's a huge operational risk. Imagine that in a customer-facing application.
The compliance evaluation revealed another pattern. Models from different regions showed distinct biases in what they considered safe. Chinese models were stricter on political content but more permissive on violence. Western models showed the opposite pattern.
So we're not even agreeing on what safety means across cultures?
Exactly. And that makes deployment in global context incredibly challenging. You might pass safety audits in one region and fail spectacularly in another. Stick around. We'll break down exactly what engineering teams should do with this information and the specific checklist you need before deploying any of these models.
All right, so given all these vulnerabilities and trade-offs, what should engineering teams actually do? We can't just not use these models.
First, throw out the idea that any single model is safe across all contexts. The report makes it crystal clear. You need to evaluate based on your specific use case, user base, and threat model.
So build our own evaluation framework?
At minimum, you need 4 layers. First, standard benchmarks. Yes, they're flawed, but they're your baseline. Second, adversarial testing specific to your domain. If you're in healthcare, test medical misinformation scenarios. Financial services, test for market manipulation attempts.
That's a lot of overhead for smaller teams.
Here's a practical approach. Start with the report's safety profiles. GPT 5.2 for general-purpose applications where you need balanced safety, Qwen 3 VL if you're serving multilingual users, Gemini 3 Pro for English-first applications with strong compliance needs.
What about the image generation use cases?
That's trickier. None of the models showed robust safety under semantic ambiguity. Your best bet is implementing multiple layers,
prompt filtering, output validation, and human review for sensitive contexts. Don't rely on the model's built-in safety alone.
Sounds like we're adding latency and complexity.
You are, but consider the alternative. One viral incident of your model generating inappropriate content could destroy user trust overnight. The report found that even GPT 5.2's image generation capabilities dropped to 71% safety under ambiguous prompts.
Any surprising recommendations from the report?
Actually, yes. They suggest using ensemble approaches, multiple models voting on whether content is safe. Combining GPT 5.2's balanced approach with Seedream 4.5's strong compliance created a system with 94% safety across all evaluation modes.
But that multiplies our API costs.
True, but they also found you can use smaller models for pre-filtering. Nano Banana Pro, despite its ridiculous name, is incredibly efficient for first-pass safety checks. Use it as a gatekeeper before your primary model.
What should we watch for going forward?
The report hints at something concerning. The gap between benchmark and adversarial performance is growing with each model generation. GPT-4 had a 12-point gap. GPT 5.2 has an 18-point gap. We're getting better at benchmarks, but not at real-world robustness.
So the problem's getting worse as models get more sophisticated?
Different problem. The attack surface is expanding faster than our ability to defend it. Every new capability, video understanding, code generation, multi-turn reasoning, introduces new vulnerabilities we haven't figured out how to evaluate properly.
Final thoughts. What's the one thing teams should do tomorrow?
Run adversarial evaluations on your current deployments. I guarantee you'll find vulnerabilities you didn't know existed. Start with the prompts from this report's appendix. They've open-sourced their entire evaluation suite.
That's actually incredibly valuable.
Here's my takeaway. We're in an arms race between capability and safety. And right now, capability is winning. But reports like this give us the tools to fight back. The key is acknowledging that safety isn't a feature you can bolt on. It's a continuous process that needs to evolve with your deployment.
And probably needs to be someone's full-time job at this point.
If you're deploying frontier models to millions of users, it needs to be several people's full-time jobs. The heterogeneous landscape this report revealed means you can't just pick a safe model and forget about it. Safety is contextual, multilingual, multimodal, and constantly evolving. Plan accordingly. That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
Until next time.